Paper is a thin sheet of matted cellulose fibers. Largely derived from lignocellulose, paper is created from a pulp dissolved into a slurry that is drained and dried into sheets. Different types of paper are defined by constituent fiber: paper pulp, sizing, coating, paper size, paper density, and grammage. The paper-making process developed in East Asia at least as early as 105 CE by the Han court eunuch Kai Lun, although archaeological evidence exists of 2nd century BCE paper-like material in China. Before the industrialization of paper production, the most common paper was rag paper, made from discarded natural fiber textiles collected by rag pickers. The 1843 invention of wood pulp, coupled with the Second Industrial Revolution, made pulpwood paper the dominant variety to this day. Etymology. The word paper is etymologically derived from Latin papyrus, which comes from the Greek pi alpha pi upsilon rho omicron sigma, papyros, the word for the cyperus papyrus plant. Papyrus is a thick, paper-like material produced from the pith of the cyperus papyrus plant, which was used in ancient Egypt and other Mediterranean cultures for writing before the introduction of paper. Although the word paper is etymologically derived from papyrus, the two are separate technological developments that use different materials and production methods. Papyrus is a lamination of natural plant fiber, while paper is manufactured from fibers whose properties have been changed by maceration. History. Main article: History of paper. Precursors. Paper was preceded by and coexisted with other early writing materials, such as papyrus, parchment, vellum, bark cloth, birch bark, palm leaves, and bamboo and wooden slips. Papyrus, superficially similar to paper, has several downsides that eventually caused it to be replaced by paper. It was geographically limited to a plant primarily grown in Egypt. It was both more expensive and laborious to produce compared to paper, and it was more fragile and sensitive to moisture, making it prone to break apart in damp conditions. Invention and development. Hemp wrapping paper, China, c. 100 BCE. The oldest known archaeological fragments of the immediate precursor to modern paper date to the 2nd century BCE in China. The pulp paper-making process is ascribed to Kai Lun, a 2nd century CE Han court eunuch. In the 13th century, the knowledge and uses of paper spread from the Middle East to medieval Europe, where the first water-powered paper mills were built. Because paper was introduced to the West through the city of Baghdad, it was first called Bagdatikos. In the 19th century, industrialization greatly reduced the cost of manufacturing paper. In 1844, the Canadian inventor Charles Fennerty and the German inventor Friedrich Gottlob Keller independently developed processes for pulping wood fibers. Battle of Talas. Main articles: Battle of Talas section Papermaking and Samarkand paper section History. Popular history points to the Battle of Talas in 751 CE as when papermaking spread to the Islamic world, purporting that Tang dynasty papermakers were captured as prisoners and used to extract the secrets of papermaking. However, archaeological finds from 313 CE in Samarkand suggest paper's presence outside China centuries before. Papermaking. Main article: Papermaking. Pulp. Main article: Pulp paper. Pulp is a lignocellulosic mixture of isolated fibers. Traditional low-lignin pulp sources like rags and paper mulberry can be mechanically broken down. Industrial pulp making largely makes use of pulpwood, which can be pulped chemically or mechanically. Chemical pulping main articles: Craft process, sulfite process, and soda pulping. To make pulp from wood, a chemical pulping process separates lignin from cellulose fiber. A cooking liquor is used to dissolve the lignin, which is then washed from the cellulose. This preserves the length of the cellulose fibers. Paper made from chemical pulps are also known as wood-free papers, not to be confused with tree-free paper. This is because they do not contain lignin, which deteriorates over time. The pulp can also be bleached to produce white paper, but this consumes 5% of the fibers. Chemical pulping processes are not used to make paper made from cotton, which is already 90% cellulose. The microscopic structure of paper. Micrograph of tissue paper autofluorescing under ultraviolet illumination. The individual fibers in this sample are around 10 μm in diameter. There are three main chemical pulping processes. The sulfite process dates back to the 1840s and was the dominant method before the Second World War. The Kraft process, invented in the 1870s and first used in the 1890s, is now the most commonly practiced strategy. One of its advantages is the chemical reaction with lignin produces heat, which can be used to run a generator. Most pulping operations using the Kraft process are net contributors to the electricity grid or use the electricity to run an adjacent paper mill. Another advantage is that this process recovers and reuses all inorganic chemical reagents. Soda pulping is another specialty process used to pulp straws, bagasse, and hardwoods with high silicate content. Mechanical pulping: there are two major mechanical pulps: thermomechanical pulp, TMP, and groundwood pulp, GW. In the TMP process, wood is chipped and then fed into steam-heated refiners, where the chips are squeezed and converted to fibers between two steel discs. In the groundwood process, debarked logs are fed into grinders where they are pressed against rotating stones to be made into fibers. Mechanical pulping does not remove the lignin, so the yield is very high, greater than 95%. However, lignin causes the paper thus produced to turn yellow and become brittle over time. Mechanical pulps have rather short fibers, thus producing weak paper. Although large amounts of electrical energy are required to produce mechanical pulp, it costs less than the chemical kind. Recycling and de-inked pulp, a process for removing printing inks from recycled paper, was invented by German jurist Justus Klaproth in 1774. Today this method is called dinking. Paper recycling processes can use either chemically or mechanically produced pulp. By mixing it with water and applying mechanical action, the hydrogen bonds in the paper can be broken and fibers separated again. Most recycled paper contains a proportion of virgin fiber for the sake of quality. Generally speaking, de-inked pulp is of the same quality or lower than the collected paper it was made from. There are three main classifications of recycled fiber: mill broke or internal mill waste. This incorporates any substandard or grade change paper made within the paper mill itself, which then goes back into the manufacturing system to be repulped back into paper. Such out-of-specification paper is not sold and is therefore often not classified as genuine reclaimed recycled fiber. However, most paper mills have been reusing their own waste fiber for many years, long before recycling became popular. Pre-consumer waste. This is off-cut and processing waste, such as guillotine trims and envelope blank waste. It is generated outside the paper mill and could potentially go to landfill, and is a genuine recycled fiber source. It includes de-inked pre-consumer waste, recycled material that has been printed but did not reach its intended end use, such as waste from printers and unsold publications. Post-consumer waste. This is fiber from paper that has been used for its intended end use and includes office waste, magazine papers, and newsprint. As the vast majority of this material has been printed, either digitally or by more conventional means such as lithography or rotogravure, it will either be recycled as printed paper or go through a de-inking process first. Recycled papers can be made from 100% recycled materials or blended with virgin pulp, although they are generally not as strong nor as bright as papers made from the latter. Producing paper. Main articles: paper machine and paper making. Paper mill in Mäntyvilppula, Finland. The pulp is fed to a paper machine, where it is formed as a paper web, and the water is removed from it by pressing and drying. Pressing the sheet removes the water by force. Once the water is forced from the sheet, a special kind of felt, which is not to be confused with the traditional one, is used to collect the water. When making paper by hand, a blotter sheet is used instead. Drying involves using air or heat to remove water from the paper sheets. In the earliest days of papermaking, this was done by hanging the sheets like laundry. In more modern times, various forms of heated drying mechanisms are used. On the paper machine, the most common is the steam-heated can dryer. These can reach temperatures above 93 degrees C, 200 degrees F, and are used in long sequences of more than 40 cans, where the heat produced by these can easily dry the paper to less than 6% moisture. Paper grain. All paper produced by paper machines, such as the Fourdrinier machine, are wove paper. That is the wire mesh that transports the web, leaves a pattern that has the same density along the paper grain and across the grain. Textured finishes, watermarks, and wire patterns imitating handmade laid paper can be created by the use of appropriate rollers in the later stages of the machine. Wove paper does not exhibit laid lines, which are small regular lines left behind on paper when it was handmade in a decal mold made from rows of metal wires or bamboo. Laid lines are very close together. They run perpendicular to the chain lines, which are further apart. Handmade paper similarly exhibits decal edges or rough and feathery borders. Sizing and finishing. Further information: sizing and coated paper. Lower quality paper, used to print the book in 1991, with visible bits of wood. Papers may have their surfaces polished by calendaring or burnishing. Paper can be further processed into coated paper by sizing the paper with a thin layer of material, such as calcium carbonate or kaolin, applied to one or both sides. This treatment manipulates the final feel of the paper, which improve its characteristics for specific purposes, such as avoiding ink running on printer paper. The paper is then fed onto reels if it is to be used on web printing presses or cut into sheets for other printing processes or other purposes. Sheets are usually cut long grain, that is, with the grain parallel to the longer dimension of the sheet. Continuous form paper, or continuous stationery, is cut to width with holes punched at the edges and folded into stacks. Applications. Further information: list of paper products in category paper products. Shutterstock. Paper money from different countries. It is estimated that paper-based storage solutions captured 0.33% of the total in 1986 and only 0.007% in 2007. Even though in absolute terms the world's capacity to store information on paper increased from 8.7 to 19.4 petabytes. It is estimated that in 1986, paper-based postal letters represented less than 0.05% of the world's telecommunication capacity, with sharply decreasing tendency after the massive introduction of digital technologies. Paper has a major role in the visual arts. It is used by itself to form 2- and 3-dimensional shapes and collages. It has also evolved to being a structural material used in furniture design. Watercolor paper has a long history of production and use. Types, thickness, and weight. Main articles: paper size, grammage, and paper density. Card and paper stock for crafts. Use comes in a wide variety of textures and colors. The thickness of paper is often measured by caliper, which is typically given in thousandths of an inch in the United States and in micrometers, μm, in the rest of the world. Paper may be between 0.07 and 0.18 millimeters, 0.0028 and 0.0071 in thick. Paper is often characterized by weight. In the United States, the weight is the weight of a ream bundle of 500 sheets of varying basic sizes before the paper is cut into the size it is sold to end customers. For example, a ream of 20 pounds, 8.5 in times 11 in 216 millimeters times 279 millimeters. Paper weighs 5 pounds because it has been cut from larger sheets into 4 pieces. In the United States, printing paper is generally 20 pounds, 24 pounds, 28 pounds, or 32 pounds at most. Cover stock is generally 68 pounds, and 110 pounds or more is considered cardstock. In Europe and other regions using the ISO 216 paper sizing system, the weight is expressed in grams per square meter, GM2, or usually GSM of the paper. Printing paper is generally between 60 GSM and 120 GSM. Anything heavier than 160 GSM is considered card. The weight of a ream therefore depends on the dimensions of the paper and its thickness. Most commercial paper sold in North America is cut to standard paper sizes based on customary units and is defined by the length and width of a sheet of paper. The ISO 216 system used in most other countries is based on the surface area of a sheet of paper, not on a sheet's width and length. It was first adopted in Germany in 1922 and generally spread as nations adopted the metric system. The largest standard size paper is A0, a zero, measuring 1 square meter, approx. 1189 times 841 millimeters. A1 is half the size of a sheet of A0, i.e., 594 millimeters times 841 millimeters, such that 2 sheets of A1 placed side by side are equal to 1 sheet of A0. A2 is half the size of a sheet of A1, and so forth. Common sizes used in the office and the home are A4 and A3. A3 is the size of 2 A4 sheets. The density of paper ranges from 250 kilograms M3, 16 pounds/QFT, for tissue paper to 1,500 kilograms M3, 94 pounds/QFT for some specialty paper. Printing paper is about 800 kilograms M3, 50 pounds/QFT. Types of paper. Main article, list of types of paper. Paper may be classified into 7 categories. Printing papers of wide variety. Wrapping papers for the protection of goods and merchandise. This includes wax and craft papers. Writing paper suitable for stationery requirements. This includes ledger, bank, and bond paper. Blotting papers containing little or no size. Drawing papers usually with rough surfaces used by artists and designers, including cartridge paper. Handmade papers including most decorative papers, Inger's papers, Japanese paper, and tissues, all characterized by lack of grain direction. Specialty papers including cigarette paper, toilet tissue, and other industrial papers. Environmental impact. Main articles, environmental impact of paper and deforestation. The production and use of paper has a number of adverse effects on the environment. Worldwide consumption of paper has risen by 400% in the past 40 years, leading to increase in deforestation, with 35% of harvested trees being used for paper manufacture. Most paper companies also plant trees to help regrow forests. Logging of old-growth forests accounts for less than 10% of wood pulp, but is one of the most controversial issues. Paper waste accounts for up to 40% of total waste produced in the United States each year, which adds up to 71.6 million tons of paper waste per year in the United States alone. The average office worker in the U.S. prints 31 pages every day. Americans also use in the order of 16 billion paper cups per year. Conventional bleaching of wood pulp using elemental chlorine produces and releases into the environment large amounts of chlorinated organic compounds, including chlorinated dioxins. Dioxins are recognized as a persistent environmental pollutant, regulated internationally by the Stockholm Convention on Persistent Organic Pollutants. Dioxins are highly toxic, and health effects on humans include reproductive, developmental, immune, and hormonal problems. They are known to be carcinogenic. Over 90% of human exposure is through food, primarily meat, dairy, fish, and shellfish, as dioxins accumulate in the food chain and the fatty tissue of animals. The paper, pulp, and print industries emitted together about 1% of world greenhouse gas emissions in 2010 and about 0.9% in 2012. Current production and use. In the 2022-2024 edition of the annual Pulp and Paper Capacity Survey, the Food and Agriculture Organization of the United Nations, FAO, reports that Asia has superseded North America as the top pulp and paper-producing continent. FAO figures for 2021 show the production of graphic papers continuing its decline from a mid-2000s peak to hover below 100 million tons a year. By contrast, the production of other papers and paperboard, which includes cardboard and sanitary products, has continued to soar, exceeding 320 million tons. FAO has documented the expanding production of cardboard in paper and paperboard, which has been increasing in response to the spread of e-commerce since the 2010s. Data from FAO suggest that it has been even further boosted by COVID-19 related lockdowns.